Hi, this is Radhika Chevkula and my research project is Airport Shopping Simulation. It's an agent-based simulation model. A little background on this. This was a research paper that was published in a conference in winter 2019. It's titled Airport Passenger Shopping Modeling and Simulation Targeting Distance Impacts. This paper basically talks about the decision-making process of a passenger and how it's affected by some of the key factors that are identified here below, such as gender of the passenger, travel purpose, dwell time, and shop-to-passenger distance. The model talks about the relationship between the decision-making process of the passenger and the various key attributes. So they've come up with a formula that you can see here, playing out the various factors and seeing how their interaction is basically. Some of the potential factors that would really affect our model are basically age of the passenger, length of the stay, and size of the terminal. I believe that these factors could play a significant role, just because say for example each of the passenger, right? Say if I'm a young person, I wouldn't really mind walking for like 15 minutes and getting something that I really like. But say I'm a 60-year-old woman, I would rather just get a coffee or cold drink that's nearby rather than walking for 15-20 minutes. Same with length of stay and size of the terminal. I wouldn't want to walk to the other side of the terminal just to get something I really like. We will be using NetLogo, which is an agent-based simulation model that will allow us to create the model and execute the simulation with a lot of these key factors as input parameters, and we will be able to test different scenarios. This is the NetLogo web version of the model. As you can see in the simulation space, I have people, men as blue and women as pink. And the small boxes that you see here are stores that people go to shop. And I have implemented all the variables here on the left side, such as people at the airport, age of the passenger, store number, how many stores are there, length of their stay, etc. And you see here there are two new variables: initial explore time, which gives us how much time in seconds does a passenger take to explore his or her surroundings, and the initial percentage is following basically an assumption that not everybody at the airport is there to explore or shop. Some people just want to sit at their zone. So a total number of three plots have been built in this model to give us an understanding of what's happening. The first one here is the shopping plot, which gives us the count of total number of people who are shopping versus who are non-shopping. So if you see the line here, it's almost that the same number of people are shopping and that the same number of people are waiting at the gate. This plot gives us a total number of people who are waiting to board the plane at the departure zone. Again, if you see, this number keeps changing a bit because the people do not just sit there. They explore all places or they go out for shopping and then they come back. This plot gives us an understanding of how many people are actually shopping at the different stores. Say, for example, if the store number is given as 3, that means there are 3 different stores in the space and shoppers have an option to go to all the 3 stores. Then this plot is giving us the total number of people at each of those 3 stores. Two different scenarios are tested to check the accuracy and the performance of the model. The first one is that older people will not travel a long distance and shorter stay people will not go shopping. So both of these can be determined by the two variables that we have implemented in the model, age of the passenger and length of the stay. So we have built in a condition that if the age of the passenger is greater than 70, then they will not really move. They'll just stay at their departure zone. And say length of the stay is less than 30 minutes, then they're waiting to already board their plane, so they're not going to go move around much. And this model gets too complex when I try to add new variables in NetLogo. So if one wants to extend this model and continue the study further, I would suggest that they have an in-depth knowledge of NetLogo, or they just find a other simulation environment which is probably easier to use, because there are so many other interesting factors such as the layout of the terminal, which type of retail store is it, if it's a clothing store or if it's an eatery, and what about the income of the passengers, because all these affect the decision making process of the passenger. This is the airport simulation model I have, where a passenger's decision-making process is affected by various other factors in the airport environment. Please let me know if you have any questions. You can reach me via email, and thank you so much for watching this.